Expanding logarithmic expressions. So in this, what we're going to be doing is putting together our product, our quotient, and our power rules to expand these fully. So one at a time here. We'll go through these kind of quickly, but hopefully we can pay attention and get it down. So we have log base b of 6x all divided by y. So as I get going on this, what I'm going to first do is factor anything that I possibly can. So a composite number such as the 6, I'm going to rewrite that as 2 times 3 instead of 6. Just speeds this up if you do the factoring from the very beginning. So what we're going to do next is each term that came from, each factor that comes from the numerator gets its own log. It's going to be positive out in front. Each factor from the denominator, I'm looking at uy, gets its own log, but it's going to be negative out in front. So jumping straight to our answer, we have log base b of 2, positive out in front, came from the numerator, plus log base b of 3, positive out in front, came from the numerator, plus log base b of x, positive in front, came from the numerator, log base b of y, but here's where you want to be careful. It's going to be a subtraction or negative out in front because the y came from the denominator. There you have it. All right, what about we introduce an exponent in this one? We have a natural log of x to the 4th times y all over 7. Can't factor the 7. Nice prime number from the beginning. So let's work on first just rewriting these, splitting these apart. Natural log is a log. It gets all the properties of logarithms. So I'm going to start by saying natural log of x to the 4th. X to the 4th is multiplied by everything else. Therefore, it's a factor. So I'm going to give it its own log. It came from the numerator, so it's going to be positive out in front. Natural log of y came from the numerator, positive in front. Natural log of 7 came from the denominator, negative in front. Last thing we can do to expand this out a little bit further, I'm looking at this exponent. It's attached to everything on the inside of this logarithm. That's going to move down in front and become a multiple. So we can say 4 multiplied by natural log of x plus natural log of y minus natural log of 7. Fully expanded, we're done. All right. And you'll get used to these exponents coming down in front. I'm just trying to take my time and make it a couple steps as we're going through these. So common log, log base 10 of x to the 15th times y to the 13th, all over z to the 19th. Again, I'm just going to jump right into log x to the 15th. Gets its own log. It's going to be positive in front because it came from the numerator. Log of y to the 13th gets its own log. It's going to be positive in front because that came from the numerator as well. And finally, log of z to the 19th gets its own log, but this time it's going to be negative out in front because that came from the denominator. The last thing we can do to expand is now we have exponents attached to everything on the inside. These exponents can be moved down in front to fully expand this and say 15 times log of x plus 13 times log of y minus 19 times log of z, and we're fully expanded. Now what happens if they throw negative exponents our direction? Now we could just deal with negative exponents as they come, approach it in a similar fashion and bring them down in front after we split this apart. But how I like to do this is first just rewrite this without any negative exponents. So if it has a negative exponent, I want to get rid of that by moving this from numerator to the denominator. What I mean by that is if it has a positive exponent, we'll leave it where it is. If it has a negative exponent, we change from numerator to denominator or vice versa and make them into positive exponents. So a to the negative second, we have a negative exponent. Let's move that down to the denominator and make it a positive exponent. B to the negative 4th, we have a negative exponent. Let's make it positive by moving up to the numerator and make it a positive exponent. The c to the 5th, positive already. We're going to leave it where it is down in the denominator. Now that everything has positive exponents, let's work on splitting this apart. So natural log b to the 4th, that's going to be positive out in front because it came from the numerator. Natural log of a to the 2nd power, that's going to be negative out in front because that came from the denominator. Natural log of c to the 5th gets its own log, but it's going to be negative in front because it came from the denominator. Last thing we need to do on this one is move these exponents down. They're attached to everything on the inside of the log. So we can fully expand this by saying 4 natural log of b minus 2 natural log of a minus 5 natural log of c. That's as far as that one's going to expand. Let's get into a couple more difficult ones to finish this video out. So if you look at something like this, we have 64x to the third power multiplied by the quantity 4x plus 1, all divided by 2x minus 1. That's inside of a logarithm with base 6. So the first thing I would do on this is that 64 is not a prime number. I would maybe just go off to the side and say, how do I factor 64? Well, there are several different ways you can get started on this. I don't know, 8 times 8 is one way to factor it. But 8 is not a prime number, so keep going. Maybe 2 times 4. 4 is not a prime number, so we can keep going on that as well. When we look at the bottom of this, all of these branches, if you multiply those all together, looks like 6 copies of 2. If you multiply those all together, you get 2 to the 6th power. That's equivalent to the 64. So I'm going to visualize this as 2 to the 6th power from the very beginning. So factor any composite numbers as much as possible from the beginning, and it's going to speed up our whole process. So from here, let's go ahead and start splitting this apart. We're going to give each one of these a log base 6. First one is going to be 2 to the 6th power. It's going to be positive in front because that came from the numerator. We're going to give log base 6 to an x cubed. That's going to be positive in front because it came from the numerator. We're going to give a log base 6 to that set of parentheses, the 4x plus 1. Again, positive because it came from the numerator. And lastly, a log base 6 of 2x minus 1, but that one's going to be negative out in front because it came from the denominator. All right, the last things we can do to expand this just a little bit more are if we have an exponent attached to everything on the inside of a log, that can come down in front and become a multiple. Same thing over here with this 3 for an exponent. So final answer here is just going to be 6 multiplied by log base 6 of 2 plus 3 multiplied by log base 6 of x plus bring everything else down, log base 6 of 4x plus 1 minus log base 6 of 2x minus 1. Let's stop the video right there. That'll accomplish basically everything we need to learn in this. So hope this helps out as you're working on expanding logarithms. Be careful, every factor gets its own log. Just make sure that if it came from the numerator, it's going to be out positive out in front of that log. If that factor came from the denominator, it's going to be negative in front of that log. Only move these exponents down when they're attached to everything on the inside of the logarithm. Hope this helps.